Hey, seventh grade. So on Monday, we had our activity where we went around and we measured all of the different circumferences and diameters of the round things in our homes. And most of your numbers came really close to 3.1 something. Um, there were a few that were like 3.48 or 3.56 or things like that. And how I justify that is that you were a little bit um, imprecise with your measurement. If we had done this in millimeters and measured to the nearest millimeter, we may have seen a lot more um, consistency with our measurements. But you guys did a great job. So awesome. Good for you. And your numbers tended to be pretty consistent. So in our book yesterday, we read that pi is approximately equal to 3 and 1/7. Now, of course, 1/7 is a rational number. And we talked at the beginning of the year how pi is not a rational number. And so as we have progressed further and further, I don't know if you guys read the third page on the paper that you could record your measurements on Monday, but that kind of gave a brief history of pi over the years. And as we have gotten more technologically advanced and been able to measure circles with more precision, we have been able to kind of determine what pi is much more closely. And so when I was in elementary school, we used 22/7, which is 3 and 1/7. But as we progress through the higher grades, we need to be more precise. And so if you get into an engineering class, you may have to go out to 4 or 5 decimal points just for accuracy's sake. So let's talk really quick about what pi is. Pi is the ratio between any circle's circumference and its diameter. Let me do this. All right, so let's see. This is pi. This is a Greek letter, kind of like P, but it's Greek. And so that's pi. And it is equivalent to the ratio of the circumference divided by the diameter. And as we remember these little squiggly equal signs, that means approximately equal to. So about 3.14159265358. And I'm going to attach the pi song just for fun because it's lighthearted and it's really catchy and it gets stuck in your head. But anyway, so that right there, that right there is about what pi is. And we are going to use pi. There is a pi button in scientific calculators, and whenever you get to geometry, high school geometry, you are going to be using that for accuracy. But what we are going to do is we are going to say that pi is 3.14 for all of our work here. Pi is going to be 3.14. Unless it says leave it in terms of pi, but we're not going to get to that this year. We'll do that next year. All right, so here real quick, this is your worksheet, and I'll do some examples on this other page in a minute just to show you what we're doing. But I wanted to start with this one because it has like this little note part up here. And so remember, the radius is halfway to the circle. So from the center to a point on the circle. Right now, the diameter is given. So the diameter is there. The radius is half of that. And then the circumference, all right, so back to this real quick. The circumference has a relationship with pi and the diameter already. And so if I rearranged this, I could say, let's see, if I multiplied this by the diameter on both sides, then I would get C by itself. And so that right there says that C is equal to pi times the diameter. And Sorry, there we go. And that's how we get the circumference formula. Now, I am not going to show you how we get the area formula because that requires some really cool graphics and a rectangle cut into pieces. But yeah, this is how we get the circumference formula. All right. So that's over there now. The area formula is pi r squared. Now, here's something that I had my kids last year recite over and over and over and over and over again. Cherry pie is delicious. Apple pies are too. Now, watch this. Watch this. You're going to love this, okay? Cherry pie is delicious. Let us say that we can represent cherry pies. Oh dear, I forgot it. There it is. There it is. Cherry pies delicious. C equals pi d. And apple pies, pi are 2. Let me blow this up a little bit so that you can really see what I'm getting at here. So, cherry pies delicious, apple pies are 2. Cherry pies delicious, apple pies are 2. Cherry pies delicious, apple pies are 2. Cherry pies delicious. Apple pies are 2. Now, I don't care very much for cherry pie. Maybe it could be chocolate pie is delicious and apple pies are 2. But, whatever. That's not the point. The point is that it's a mnemonic to make you remember these formulas. So, cherry pie is delicious, apple pies are 2. You say it. Do you sound crazy? That's okay because you're, holed up in your room or whatever. So, cherry pie is delicious, apple pies are 2. Cherry pie is delicious, apple pies are 2. Now that you've got that stuck in your head forever, let's get back to using them. So cherry pie is delicious. All that you're doing here is multiplying. And same over here. Now, the only thing we need to remember is that the only thing that's being squared is the radius. Here they went ahead and put their units in. I'm not a super duper fan of that. I would rather wait and put the units at the end, but whatever. So the only thing that you're going to square here is 5.3. Remember that means 5.3 times 5.3. So I'm going to show you how to put this in the calculator in 1 hot second. Are you ready? Great, here we go. So here, the radius on this circle, well, it gives us the diameter, which is 8 feet. So the radius is 4 feet. Why is it not typing? Oh, that's why. Okay, so 4 feet. And then the diameter is already given, and so that's 8 feet. And then the area. So I have my calculator here. And I'm going to scoot it over just a wee bit so that I can, there we go. So area, cherry pie is delicious, apple pies are 2. So pi is 3.14 times radius times radius. That's what r squared means. So 4 times 4. And that's going to give me 50.24. 50.24, and area is in square feet. So feet, I'm just going to put an SQ there, square feet, okay? Circumference then, oh dear. Circumference then, cherry pie is delicious. Right, so that means that I need to clear this out. There we go. 3.14 times the diameter. The diameter is 8. Got this. 25.12. Now, here we see that these two are half, like this one's half of that. Is that always going to be the case? Okay, I'm going to stop you right there and tell you, heck no. I have seen circles where their circumference and the area are the same number. And I have seen circles where there's a big difference between these two. This just happens to be one of those really cool numbers that works out this way. All right, so let's try another one. On this one, the radius is already given to us, so that's 7 feet. Next, diameter then is twice as big, so that's 14 feet. Okay, the area, well, excellent. It's already It's already all written there, so all I need to do is plug it into the formula. So cherry pie is delicious. Apple pies are too. Pi, 3.14, times the radius, and the radius is 7. 7 times 7 is 49. I'm going to go ahead and skip that step right there because I know my perfect squares. You should too. I think you do. So 3.14 times 49 is 153.86. 153.86, and again, that is in square feet. Next, the circumference. So clear this, and let's say cherry pie is delicious. So 3.14 times the diameter, which is 14. There we go. 43.96, and that's just in feet. And the reason that this is just in feet is because that's how many feet of ribbon do I need to go around this circle, or how many feet of bricks do I need to go around this garden planter, or whatever. And that's going to be in just feet. Square feet means how much space does this take up? And I know you remember this. Alrighty, so there's that. Those are pretty straightforward. I want to see if there's any here with a decimal on it because, oh no, not decimals. There's not. Okay, all of these ones are super duper easy. The ones that you're going to have, oh no, not a decimal. Again, not a big deal. You just take that and divide it by 2 in your calculator. So not a big deal. And that's pretty much all it is you're just multiplying using the formula. So if you have any questions, please do not hesitate to reach out to me. If you want to use Kami, but you're having a hard time making it work, here's a couple of things. Most of the time, it's going to start you with the pointer tool selected. And so if you go down to the T, the text box, and choose that one, and then you just click where you want to put the box and start typing away, then there you go. You saw on the other one, I was able to, do that with just making an enter space between, but these are a little bit smaller. And so you can just make your text box here, and your text box here, and your text box here. Oh, there. And then move it up a little bit, I guess. But if you would rather type number 1, A, B, C, D on like our radius, diameter, circumference, area on a doc and submit that, then, that's totally your business. Show your work. Again, that just means, type out what did you put in the calculator. So on this one, cherry pie times the diameter. So cherry pie is delicious, right? And then you just type in what numbers you put in there. The circumference is 3.14 times whatever the diameter is. Some number, right? And then you just say that the circumference is 72. Now, given that pi is a decimal number, most of these are going to have decimal answers as circumference and area. All right, so that's pretty much all I got. If you have any questions, either with the content or how to make the Kami work for you, then let me know, and I will talk to you about it. All right, so you guys have a great rest of the day, and I will see you tomorrow for a really cool moon project. Bye-bye.